Good morning students, this is Dr Smita R Kabbur, Assistant Professor, Department of Mathematics, KLS, Gopte Institute of Technology, Belgaum. Done with your results with flying colors. Now we are going to start with CET preparations. Today's or in this video lecture, I'll be covering relations and functions chapter. Relations and functions. The first question to start is, let A be a set with 1, 2, 3, 4 as elements, B as 1, 2, 3, 4, 5, 6. A question is, how many number of functions are defined from A to B? 1296, 4096, 360, 1560. Now, how do we define a function? You have to be a function from A to B. A is a domain, B is a codomain. Cardinality of a set A defined as n of A. Number of elements in a set A, 4. Cardinality of B, n of B is 6. Hence, in A cross B, we have 6 into 4, 24 number of elements. Now, what is asked? How many functions are defined from A to B? We'll go for a generalized result. Formula says, number of elements in codomain B, 6, raised to number of elements in domain. So it will be 6 raised to 4, 1296. Hence the answer for a question, number of functions from A to B will be 1296. Option number A you can see here. Now, in case the question is how many functions, then the number of functions from B to A are. B to A are. So what will be the answer? Here codomain is A. Hence, in codomain we have 4 elements. Domain we have 6 elements. Hence 4 raised to 6, 4096. So 4096 will be answer for a question functions from B to A. What if the question is then the number of 1 functions from A to B? I repeat, then the number of 1 functions from A to B. So what is the formula? Number of functions from A to B. A taking as domain, B as codomain. The definition says if m is less than or equal to n, or we shall go for generalization. Number of elements in domain less than or equal to number of elements in codomain, then the number of 1 functions defined are n factorial by n minus m factorial 360. What is example given to us? In A we have 4 elements, B 6 elements, hence the condition is satisfied 4 less than or equal to 6. Substituting the values of n, m, we get the answer as 360. In case if we have m greater than n, that is in domain we have elements more than elements in codomain, we cannot define 1 function because every elements in domain must have different elements images in codomain. If I have 6 elements in domain and 3 elements in codomain, we can clearly observe that 3 elements are left without images. Clear observation. Hence, it will not be a 1 function. Suppose, if the question is, how many onto functions are? We'll say, then the number of onto functions from A to B are. Come back to the definition. Number of onto functions from A to B. Number of onto functions from A to B defined as, again with the condition m less than n. If I have 4 elements in domain and 6 elements in codomain, if it has to be an onto function, with the definition, all elements of the codomain must be images. But if you see that 6 elements means only 4 elements are connected to elements of a set B, hence it will not be a onto function. So what happens if I have m less than n? It will not be an onto function. Suppose a question is number of onto functions from B to A. I repeat, number of functions from B to A. So in B we have 6 elements, A we have 4 elements. Hence I can define onto functions, and the number of onto functions is calculated by using a formula. Sum k is equal to 0 to n minus 1 raised to k, n c n minus k raised to m. Substitute the values of n, m, k, you will get the answer as 1560. So let us just revise with the first example. What is 1296 answer? If the question is number of 1 functions from A to B, 4096 will be number of functions from B to A. What is 360? Number of 1 functions from A to B. 1560 will be answer for number of onto functions from B to A. So this one example will clear 4 results. Go to the next question. The domain of the function sine inverse of x log of x by 3. Sorry. Just a second, please. The question is how many the domain of the function sine inverse of log of x by 3 to the base 3 is. What it says, we know sine inverse x is defined for all x in the range of -1 to +1. So taking log of x by 3 to the base 3 taking the values -1 to 1, x by 3 will be greater than equal to 3 raised to -1 less than equal to 3. Multiply by 3. 3 into 1 by 3, 1. X by 3 into 3 will be x. 3 into 3 will be 9. So for which values of x the domain exists? For all x greater than equal to 1 less than equal to 9, or it is a closed interval 1 comma 9. See the next question. On the set of positive integers, the relation R is defined as A is related to B if A and B both are odd. Then the relation is. See what we have defined. R is a relation defined on the set of positive integers, say n. So R will be subset of n cross n. It contains the order pairs of the form A comma B if A and B are both odd. Is it reflexive? 1 1 yes belongs to R because 1 is odd. 2 2 not in R because 2 is not odd. A and B both must be odd. So it is not reflexive. Is it symmetric? So let us go for the generalization. If A comma B is in R means that what is symmetric relation says? For every order pair of the form AB in R, BA must be in R. AB is present in R. So AB is present in R means A and B both are odd. If AB are odd, obviously BA are odd. So a relation is symmetric. Is it transitive? What is the definition? For every order pairs of the form AB and BC present in R, check whether AC belongs to R. For every order pairs of the form AB, BC in R, check whether AC is in R. AB is in R means A and B are odd. BC in R means B and C both are odd. So AB, BC are odd means A and C obviously are odd, as the relation is transitive. So how is this relation? Not reflexive, symmetric, but and transitive. So if you go to the option, it is C, symmetric and transitive. A small change in the example. If I say A and B are connected by a relation is less than or is greater than. So just check with the answers. Is less than, is greater than are the relations which are not reflexive, not symmetric, but they are transitive. Less than or equal to or greater than or equal to, the relation is yes reflexive, not symmetric, but transitive. So just go on changing the definition. You can observe more results here, but be very clear with the definitions of reflexive, symmetric and transitive. Pair of lines, you can say L1 and L2 are parallel, then the relation is equivalence. L1 is perpendicular to L2, then the relation is not reflexive, it is symmetric, not transitive. Okay. For this question, answer is C. Go to the next question. Let A be a set containing 3 elements, B 3 elements. Question is the number of relations from A to B that contain exactly 5 order pairs. This is important. Exactly 5 order pairs. So let us go. Cardinality of A is 3. Cardinality of B is 3. So how much order pairs we have in A cross B? 9. What is the relation? is always a subset of A cross B. So how many relations are defined from A to B? 2 raised to 9, a basic definition. If A is a set with n elements, then the number of subsets of set A are 2 raised to n. So R, a relation from A to B, is a subset of A cross B. Hence we'll have 2 raised to 9 subsets. Or I can say there are 2 raised to 9 number of order pairs from A to B. But the question is, out of these 2 raised to 9 number of order pairs, how many of them contain exactly 5 order pairs? So, out of these 9 order pairs, I have to go on selecting 5 order pairs and form different relations. So, it is nothing but the selection. Out of 9, you select 5, use NCR formula to get 126. So the answer for the question what is asked is 126. A small change. Suppose for the same example, if they ask us how many relations are defined from A to B that contain at least 7 order pairs. I repeat, that contain at least 7 order pairs. So I should have R1 with 7 elements, R1, R11, R12 and so on. Relations which contain 7 elements, relations which contain 8 elements and relations which contain 9 elements. And the sum of these will give us the answer here. So what it will be? 9C7 plus 9C8 plus 9C9. We know the result of NCR, calculate and simplify. So relations from A to B that contain exactly will be 9C5. Suppose if I say at least 7, it will be 9C7 plus 9C8 plus 9C9. If I say at most, then what is the meaning? From 2 raised to 9, you subtract the number of order pairs which contain at least 7. So it will be 2 raised to 9 minus NC5, 9C7 plus 9C8 plus 9C9. So just go on changing the definition and think of different examples. Okay. Let me go to the maybe a last question. For a real x, function is defined as x cube plus 5x plus 1. Then what is the function? 1, 1 but not onto but not 1, 1. Both 1, 1 and onto, neither 1, 1 but not onto. How we have defined a function as a 1, 1 function? Different elements have different images, or mathematically you say that if f of x1 is equal to f of x2, then x1 is equal to x2. Okay. And how do you define onto function? Different range of a function is a codomain. Range of a function is codomain. Or one more definition I can say, for all y in the codomain, I must have an element in domain such that image of x is y. That is what we do regularly for checking whether it is 1, 1 and onto function. But what happens if function is a polynomial? You can think in a slightly a different way. Take its derivative, f dash x, 3x square plus 5. In this example, 3x square plus 5. Any real x, if you take in f dash x, 3x square, x is real, positive or negative, but x square will be positive, plus 5. So 3x square plus 5 is always positive for every real x. So what I can say, f of x is an increasing function. F of x is an increasing function. So what do I mean? Like graphically, when you say for every x, its image is different. Increasing means it goes on increasing here. So this function is 1, 1. Is it onto? Yes. Check. If I take f of x for all x tending to minus infinity, x cube plus 5x plus 1, it is minus infinity. So limit of f of x as x tends to minus infinity is infinity, and limit of f of x as x tends to infinity is infinity. Okay, so with this definition, the function will be onto, hence the function is 1, 1 and onto. Okay, so these are some examples just to revise, brush up what we have done in the regular classes. Thank you for listening to my lecture. All the best for your exams. Stay safe and do well in your exams. Thank you.